Hello and welcome to Control-Delete Tutorials. My name is Jason, and in this series of videos we're going to be talking about the AP Computer Science Principles Create Task or Create Performance Task, which is one of two parts of your AP exam. So one part being programming, which is what we're talking about, and the other part being the actual 70 some odd question exam. So first I want to go over the written responses, and not necessarily answering those written responses, but seeing how those parts are going to influence the code we are going to write. So we're just going to kind of get right into this. So this can be found on the AP website. Hopefully your teacher has it available to you, as I have this available to my students. And you're going to have three different parts here. Well, four different parts. One part is going to be a video that you are going to record showing your program actually working. Another part here is going to be the written response, which we'll have, and then you'll have your actual code that you'll turn in. And all of those parts can also be found on the AP College Board website. So the written responses, this part, very important, created independently. It means you work on this part alone. So if you've been creating your code with someone else or having somebody else help you, this part you have to do on your own. Likewise, if you're working with a partner, they would have to work on their own. And a couple of things about this. One, you cannot self-identify in any part of the AP task. So that means no putting your name on files. So if you have your project pulled up, and let's say we doing a Control-Alt-L here to pull this up. I have files over here on the side. Nothing here has my name on it. I'm not naming any of the files my name. I'm not naming anything with regards to myself. I would include in that not putting anything that has to do with your school or any sort of affiliation. Nothing that identifies to you. Okay, so super important there. Okay, so the first part here, so this is going to be 750 words for the entire thing. That does not include your program code. That's just your 3A to 3D responses. And we'll talk about those. Each one has a suggested limit for each part. It does seem like you can go over, but I would try to keep it right around that amount without going over. Okay, so the first part, 3A, all has to do with the video that you're going to record. So record a video of your program, and then you'll fill out this section here. 3A, provide a written response that does all three of the following. It's going to be 150 words for all parts of 3A. So those will be first, second, and third part of 3A. I would recommend that whenever you're writing these responses that you write to the prompt. So for instance, your prompt here says describes the overall purpose of your program. So you would start off saying the overall purpose of my program is to whatever. Okay, pretty self-explanatory there. Okay, let's go to the next part. Describes what functionality of the program is demonstrated in the video. So, what are you showing in the video? In the video, you should be demonstrating what your program does. In this part, you are simply explaining that. Okay, so the functionality. Ooh, hope my spelling's good here. Oh no. Oh boy. Okay, that's not words. Functionality. There we go. Okay, the functionality of my program shown in the video is ... Okay, what are you showing? Okay, describes the input and output of the program demonstrated in the video. Okay, so in this case, your input, for most people, this could be having the user type in some sort of information, which is what I'm going to demonstrate in the other videos. Maybe you made some sort of GUI or user interface, so pressing the buttons or typing into input fields might be your input. Okay, so assuming depending on what you have them type in, this is going to make your code run a certain way. And you will have some sort of output. Either something is displayed on the screen or something is displayed in a console window, which is what I'm going to be showing with my tutorials. So your input is what is the user inputting. The output is what do we get in return. Okay, so in this case, I would split the prompts here into two. The input being demonstrated, and the video is blah, blah, blah. Okay, and then I would have the other part as its own thing. Same idea, the output, you get the idea. Okay, so you're gonna do those individually there. Okay, so if the video is showing that the input is the user inputs text, and the text is then, something happens in the code, some functions run or something like that. You don't have to go into too much detail as far as the functions are concerned, and then whatever the output is. So that is 3A. Okay, so we're looking at 150 words for all three responses combined. Let's move on to 3B. Okay, here they say capture. I'm going to say copy because I don't know anybody that says capture and paste. But 3B, copy and paste two program code segments you develop during the administration of this task that contain a list or a collection type being used to manage complexity in your program, approximately 200 words for all subparts of 3B combined, exclusive of program code. So you will be copying and pasting or taking a screenshot of the code that you're going to talk about for this section. Now, a couple of things. College Board over here does note a list is an ordered sequence of elements, which I'm showing in the video. My video that I have two videos that I did, one on writing CSV files and one on reading CSV files. I show in there how to make a list from those, and that's what I'm going to be using to demonstrate in the videos that I'm creating. Okay, so a list or ordered sequence of elements. The use of lists allows multiple related items to be represented using a single variable. List, keep that in mind because you're going to use that in your explanation. Lists may be referred to by different names, such as arrays, depending on the programming language. Okay. So in the example I'm showing, we're going to be doing a list in Python. You could also use dictionaries. You could use a matrix, which is essentially a list of lists in Python. All of those would work. Okay, another one, a collection type. So they mentioned that up here. Collection type is a type that aggregates elements in a single structure. Some examples include lists, databases, hashes, tables, dictionaries, and sets. So those are also giving you other examples there. In our example, we make a class and we're making a list of class items. And those class items have their own elements which you can access in different parts of the code. Okay, so that's different defining parts that they have there. Okay, so the first program code segment must show how data has, I would say has, I don't know why, who types these? Okay, has been stored in the list. Okay, so we got a couple different parts we're going to break down here. Okay, must be shown. So what is your list? So how is the data stored in your list? Okay, so this might be here in the example that I'm showing. I'm reading in a CSV file, and I'm going to use the code that basically goes through, reads in the file, has a for loop that iterates through every row in the CSV file, or the file's up here, but the reader is reading that file. And then it is creating some random data based off of that information. In our case, we're using random data as just a generic. And then it is appending our list with whatever that data is, assuming there is no value errors. And in this case, our list is rand data list. So that'll be the example I use. Okay, so it must show that. Okay, the second program code segment must show the data in the same list being used, such as creating new data from the existing data or accessing multiple elements in the list as part of fulfilling the program's purpose. Okay, so I'll end up talking more in depth about this, but for now, I wrote a just small piece of code here. This is a for loop, and this for loop is going through every item in my list. Again, we're looking at items in a collection. Our item, we're just calling item, and our collection being our list. And if that item, let's say, has a float value that is greater than or equal to 7.5, here you can see I'm accessing different elements, attributes in our case, of the items in our list. So that is one example of items accessing elements. So here where they say showing data in the same list being used, which we just did, such as creating new data from the existing data or accessing multiple elements, so in that case our attributes, as part of fulfilling our program's purpose. So that's one example. I'm going to show a better example in the next video when I write code specifically to answer these different parts. So I'll show you how to do that in another video where I break each one down and show you how to write each specific section. I just realized my camera is froze, so we don't want to deal with problems today. We're just gonna, nobody needs to see my big dumb head anyway. Okay, also you can see the text I have on the side, so we'll just get rid of the cam for now. I won't put up any funny pictures this time like I did in the previous video. Alright, so anyway, yeah, so we talked about that. Okay. Then we're going to have the written responses. So here I'm going to give the two examples. So they're telling you to copy and paste them into these boxes. I would also recommend taking a screenshot of them. Okay. Then provide a written response that does all three of the following. Identifies the name of the list being used in this response. So the name of the list being used in this response is, now in my case, that would be up here, ran data list. So I'll just paste that in there. Okay, so that'd be ran data list. That's my list. Describes what the data contained in the list represents in the program. Okay, now we have another little note over here from College Board. Important. The data abstraction must make the program easier to develop. Alternatives would be more complex or easier to maintain. Future changes to the size of the list would otherwise require significant modifications to the program code. Okay, we end up talking about that later on in the some of the other parts. So describes what the data contained in the list represents in your program. All right. So in mine, I kept it fairly generic. So I could say something along the lines of each item in my list represents some random data that I have generated using a random number generator or whatever we're using. Ours is reading in from a CSV file that the CSV file was written by random number generator. So here I would have each random data set has a name identifier, a random color associated with it, a random integer, and a random float. You're going to pick the attributes that match with whatever class you ended up creating or whatever list you're working with. So I would explain that. So in the case of, let's say our class was a student, maybe this is student's first name, student's last name, student's ID number, student's GPA, student's age, things like that. Those would be different attributes that you might have in your own list. All right, going back here. I'm not going to write that one in. Okay. Explains how the selected list manages complexity in your program code by explaining why your program code could not be written or how it would be written differently if you did not use a list. Okay. They're kind of talking about part of that right here. So let's say I did not use a list. Well, okay. If all of my students that I had, so in the example I mentioned students, if all of the students that I had, if I did not use a class in this case, but if I did not use a list, all of my students would have to have individual variables for every single student that I had. So I would have to represent every student with a individual variable. Not only that, I would not be able to use what College Board refers to as iteration. So here, this is iteration. For loops and while loops is what they consider iteration. And I would not be able to use selection. Okay, selection being if statements. Selection is what College Board refers to typically as if statements. So if I did not have a list, I would have to cycle through and write code for every single every single student that is in all of the variables that I would have to generate. So I'd have to write that many lines of code for every single one. And if any students were added, I would have to manually go in and add that code for more if statements for each of them. I would not be able to use iteration. I'd not be able to cycle through all of them and just use one piece of code to check for every student in my list. Okay, I would have to individually write if statements. So if I had 500 students, I then have to have 500 if statements to check for all of their names and, student IDs and GPAs and whatever I give, attributes I give them. Okay, so if I wanted to say, look at every student's GPA that's over 3.5 or something like that, I could do that. So my code becomes more complex because I would have to use individual variables, and I would have to use individual if statements that would not automatically scale with the size of my code. Whereas if I use a list, I can put all the students in one list, and I can use for loops to cycle through every single one. And if I add a new student, the for loop automatically handles the cycling of that extra student without having to write more code. That's the general idea behind this answer, and this works for everything that we're doing with this project. Okay, so 3A and 3B are done. Okay, 3C, we're getting a little more complicated here. Copy and paste 2 program code segments you developed during the administration of this task that contain a student-developed procedure that implements an algorithm used in your program and a call to that procedure. Okay, so in this case, this call that we have is also going to be talked about in 3D, so that's important. I'm going to skip down just for a second so we can read it. Provide a written response that does all 3 of the following. Describes 2 calls to the procedure identified in 3C. So you want to make sure that you either have 2 calls or your calls are in a while loop or something like that to where you can call it multiple times from the same code. If you wanted to be on the safe side, I would write a procedure that can be called 2 different times and used 2 different ways. But in my understanding, you can use a while loop and have that function in there so it's called multiple times with different inputs from the user. We'll come back to that. Okay, 3C. So what does all of this mean? Okay, student developed procedure. Okay, a function, a simple function. So if we're in Python and I write a function, my function, in this case here, my function is read CSV, but I can't use this one because this is where I'm showing for my list. Okay, so we'll talk about another video how to write specifically for your 3C and 3D technically, because we're going to have to show where that code is called from. But we're going to have to show a procedure, so in this case a function, that takes some sort of arguments and in its parameters, and we'll show how that works. And that will make the code that's inside of here run differently based off of these arguments we put in. Okay, and again, I will show that in another video. I will write code specific to answering 3C. All right, okay, so this is a procedure. Procedure in this case is a function that implements an algorithm. Your algorithm is whatever the code is in your function. So your algorithm could be a series of for loops and if statements, which we'll see is actually part of what's down here, and we'll see how that works. So that's your algorithm. And a call to that procedure. Okay, where do I call procedure? What does that mean? Okay, right here. In my start function I made, here's me calling the start function. Okay, if I didn't have this here, none of my code would run because this function has never been called. But since I wrote start and parentheses, I'm calling this function. Inside of this function, I'm calling another function, read CSV, which takes me up here. In this case, I've put in the file that I want from my CSV as my argument. That's getting stored as my file name. And now I can open up multiple CSV files kind of with this same setup. Okay, so I have an argument here that I'm using, and I'm storing information and when I call it here. So this is me calling it. This would be a call to my function. Okay, but again, I'm going to write code specifically for these. Okay, so I've copy and pasted my 2 parts of my code. My function that I wrote that takes arguments in the parameters and all of the parts of that function within it. Okay, so this is approximately 200 words for all subsets of 3C. That might be kind of hard to see on the screen, but I'm reading that out to you there. Does not include the program code, so you do not count that towards your count. All right, so you have your different sections. The first program code segment must be a student-developed procedure that, now this is telling you how to write your specific code. What do they want the functions to be able to do? Okay, defines the procedure's name and return type if necessary. Not all functions have return types. We can specifically make a function that has a return type. So for instance, that's my desktop. For instance, let's say this bottom part I have here, and again, I'm going to show this. Let's say I didn't have this. Let's say I read my CSV file, and now I want to make it to where instead of doing this stuff here, I call a function. So I'm going to call a new function that I'm going to generate in another video. And I'm going to have that function. And so let's go back here real quick. So I'm going to have that function have a return type. So maybe it returns a sorted list, or maybe it returns, some sort of number or calculation. That could be our return type. If our function, this one's just def start, this one has no return type. We're not returning anything. Actually, this one has no return type either. But if I made a function, let's say, I'm just going to write this kind of quickly and crappily. Let's say I did def add two numbers. This is a crappy function, but it'll get the point across. Okay, I have two variables here, x and y. And inside of here, I'm saying return. So if I don't see the word, that's nice about return. If you don't see the word return, your function's not returning anything. If you're working in a different programming language like C# or Java, you'll know that your function will say like static void main, or static int, add two numbers, and this would be int x and int y. But we're in Python, we don't have to define that here. So here, what am I returning? X plus y. Okay, that would be my return type. Now, if I wanted to use that function, I can just simply say, let's say I have a variable called sum of, these are bad names, numbers. Okay, equals our function. I'm just going to copy and paste this real quick because it didn't autocomplete for me. Add two numbers. Okay, what is x and y? X is 5 and y is 10. So what happens here? We call this function. This argument gets put in as x. This argument gets put in as y. It's added together, and the value will be returned and stored to sum of numbers. Okay, that is an example of writing a function. I'm going to get rid of that. And calling it and having the code do different things, and having a return type, which is why I showed that entire thing. Okay, that would be our return type. So you would say what the procedure's name is, add to numbers. Its return type is an integer. So you want to make sure you call out the data type specifically. Okay, so our procedure needs to have a name and a return type if necessary. If it's a void type or if it's a null type, it doesn't do that. Okay, contains and uses one or more parameters that have an effect on the functionality of the code. Okay, in the previous example, let's just undo back. Okay, this one is a procedure that takes two arguments, okay, that I'm supplementing here, and it changes how the function works. I mean, it's always going to add the numbers, but it's going to return those numbers added together. So in this case, add two numbers returns the number 15 to sum of numbers. So I'm looking for a procedure I have that takes arguments into its parameters. Okay, I'm just going to leave that there for now in case we need to reference again. Okay, implements an algorithm that includes sequencing, selection, and iteration. We're going to focus on selection and iteration because sequencing can refer to just cycling through all of the information in our list. Iteration, again, is going to be for loops and while loops. Selection is going to be if statements. So if I show my desktop again. So not including this, those are not needed. So I want to look for a function that has iteration, a for loop, and ideally has selection inside of that for loop. That is your prime example of what you want to have. So for item in our list, if that item's whatever attribute here, or element as they put it, is greater than or equal to 7.5, then we're going to print out that specific item from our list. Okay, so we want a function, or to write a function that has a for loop with an if statement inside. That's like prime example. Best case scenario. You could have one that has if statements and then it has for loops inside of there. That also works. I typically choose to go iteration selection based on what they're saying. And we're sequencing, so we're going through items in our list. So we do have a set of steps that happens. Their definition of sequencing is kind of vague, but your code runs sequentially anyway. So I typically think of, we're going through the sequence of items in our list. We're using a for loop for iteration to check for each item in our list, and we're using selection to select specific items out of that list. And we would explain that here. The second program code segment must show where your student developed procedure is being called in your program. Okay, so when we write the program that we're going to write, I'm going to show where a function is called. So like here, I'm going to say this is where the function is called. It's called in this other function or whatever. So I'm going to show where that is. So I'm displaying that. Okay, must show where the procedure is being called in your program. Okay. Okay. Then provide your written responses. Okay, so the first part here is just me showing my procedure that has a name and return type, uses parameters with arguments inside of them, and has sequencing, selection, and iteration. So pasting those in here. Down here are my written responses to those. So describes in general what the identified procedure does and how it contributes to the overall functionality of the program. So let's say we wrote some sort of code that cycles through all the items in our list and adds them to a new list, something like that. So maybe it adds them to a new list, or it uses some sort of bubble sort algorithm or something to that effect. And so I'm going to, basically say, in general, let's see, the identified procedure contributes to the overall functionality of the program by taking user input to basically, let's say user input to select what information is going to be shown, and sorts all the items into a new list, and returns whatever the new list is. Okay, explains in detailed steps. So this one is in general, okay, basic steps. This one is detailed. Okay, same idea, but it's detailed. Explained in detailed steps how the algorithm implemented in your identified procedure works. Your explanation must be detailed enough for someone else to recreate it. So you're basically walking them through that code line by line. So if I was to go here, I could say, and this isn't a procedure here that takes it, but I'm just going to walk you through what I would say. So my procedure gets user input from the user, I'm pretending that part, and takes two positional arguments, one for the list and one for the sort type. And then it uses iteration to cycle, uses a for loop for iteration to cycle through all items in my random data list, and uses an if statement for selection to say if that item's random float attribute is greater than or equal to 7.5, and then prints out labeled messages to say that item's name, that item's color, that item's int value, and that item's float value by using a formatted string that looks at the item's name attribute, the item's color attribute, the item's random int attribute, and the item's random float attribute. Something to that degree. Sorry I didn't phrase that just perfectly without ums, but Okay, so that's the general idea there. Read down through your code and put it into general terms that a basic programmer could understand. Okay, so that's going to be it for 3C. Then we move on to 3D. Now, 3D is simply checking for the same code that we used in 3C, but now it's having us describe different parts. So I'll break those down. So provide a written response that does all three of the following. This is approximately 200 words for all of the subparts combined. So that is for the first call, the second call, the second part here, and the third part. Okay, and these are broken up as such. So describes two calls to the procedure identified in written response 3C. Each call must pass a different argument or arguments that cause a different segment of the code in the algorithm to execute. So in this case, we could have it to where the function takes in a list, and based off of that list, it is then going to either sort the items or pick apart certain information and make a new list out of it. And then we're going to have our two calls. So the first call and the second call. So we're calling whatever function we have, and we're going to show those calls in the previous part. And so the first call might be giving an example. So if we're using the example I talked about of a while loop, we could say an example of the first call would be for the user to input their unsorted list as the first argument, and they will write a string for the words name, in this case, name, color, int, or float. And in this example, they choose name. In the second call, they're taking the same list, but in this case, instead of using name, they use color, okay, as a string. Okay, so that would be the example I'd use if I was using a while loop. Describes what condition is being tested by each call to the procedure. So in this case, the condition being tested for my first example, so my first call being name. Okay, so this one's going to be name, this one would be color. Okay, so in this case, I could say something to the effect of, in the procedure, if the user had input a list and a name, we'll take that list and we'll use a for loop to test or check each item in that list, and to, let's say, if that item's name starts with a certain letter or something. So I could do that. I could say we're first looking for the name, and then we're given another identifier of maybe a letter or something to that degree. In my second one here,